For problem number 11, we'll be solving using the completing the square method. When we do this, we want to make sure that our leading coefficient is 1. If it's not 1, we want to divide out that leading coefficient. So for example, if there was a leading coefficient here of 2, we would divide everything by 2 to get rid of that leading coefficient. That's not the case here, so we can begin as we would like. So the first thing that I'm going to do is I'm going to subtract 6 on both sides. It's going to make my life a little bit easier. So I get x squared minus 8x equals negative 6. So if I'm completing the square, what that means is my end goal is to get some binomial times itself, which means that I would be able to write it as x plus a number or x minus a number times itself, or x plus a number squared equals some constant. So to be able to do that, I actually need to insert a value here to make a perfect square trinomial. If I'm going to insert a value, a new c, on this side, I also need to do it on this side as well to keep my equation in balance. So let's explore how we do that. So how that's going to be done is we're going to take our b term, which is negative 8, and we're going to divide it by 2, and we're going to square it. So this negative 8 divided by 2 is negative 4. We square it, we get 16. So I'm going to add 16 on both sides. So I get x squared minus 8x plus 16. Since I'm adding 16 on this side, I also have to add it on this side. So negative 6 plus 16 is going to be 10. So this now can be written as a perfect square trinomial. You can use the same strategies that we practiced in the earlier slides, factoring, factors of positive 16 that add up to negative 8. But there's a trick, and that trick comes from this here. So whatever this simplifies to, negative 8 divided by 2 is negative 4. That's going to be the value that we add or subtract. So it's x minus 4 times x minus 4. And that's equal to 10. So since I have a binomial times itself, I can now write that as x minus 4 squared equals 10. Well, I haven't even solved this yet, so now I need to begin to solve. So I'm going to do so by taking the square root, applying inverse operations. I'm squaring something, so I'm undoing that square. So I get x minus 4 equals plus or minus the square root of 10. I'll add 4 on both sides, and I get x is equal to 4 plus or minus the square root of 10. Again, I have to look at my radicand, the number underneath, and consider, are there any perfect squares that are factors of 10? So like 4, 9, 16. In this case, no. So therefore, this is our final answer.